In this video, we are going to solve the Leetcode problem of the day, and the problem is count subarray with score less than k. The problem category is of hard level, but I would say once you understand the sliding window algorithm, this will actually be a medium level of problem and not hard. And once you watch the complete video, once you understand the approach, this is actually going to be very easy to code. The given input in the problem is an array of integers nums and another integer k. The array of integers nums contains positive integers and there is another value which is k, which is also an integer, a positive integer given in the input. We need to find out, or we need to get the output as the number of subarray with score less than k. Now this k is coming from this input and you need to create the subarray from the given array nums. You need to find out the count of subarrays which has score less than k. Now how can you find the score of an array? This is very simple. If you have an array something like this which has 5 elements 1, 2, 3, 4, 5, then the score of the array is length of the array multiplied by the sum of the elements of your array. So the length is 5, 1, 2, 3, 4, 5, right? And the sum is 1 plus 2 plus 3 plus 4 plus 5, the sum of all the elements. This is 5 multiplied by 15, which is 75. So the score of this array is 75. So again, coming back to the input and output, you need to find out the number of subarray which you can create from your given input nums, which is an array of integers, such that the score of those subarrays are strictly less than k. It should not be equal to k or it should not be more than k. It should be less than k, okay? Now, there is an example given in the problem, which is 2, 1, 4, 3, 5. This is your nums and the value of k is 10. In this case, the output is 6, which is the number of subarray which has score less than 10. Why 10? Because 10 is the value of k that's given in the input. Now, what are those subarrays? It is 2, 1, 4, 3, 5 and 2, 1, right? This is one subarray, this is one subarray, this is one subarray, this is another subarray and this is another subarray, and you have 2, 1 as another subarray which has score less than 10. Any subarray which you can create apart from these will definitely have the scores either equal to 10 or more than 10. For example, let's take some random subarray. Let's take this, okay? So this subarray is 1, 4, right? The score is going to be the sum, which is 4 plus 1, 5, multiplied by the length. Length is 2, right? So 2. This is equal to 10. 10 is not less than 10, right? It should be less than 10 and not equal to as well. So we will not count this subarray. We will just count these subarrays which had score less than 10. For example, 2, 1. Now this 2, 1 has a score of 2 plus 1, which is 3. So the sum is 3 multiplied by the length, which is 2. This will be equal to 6, right? So the score of 2, 1 is 6. So this is a valid subarray which we can count. Similarly, you can find the score of other subarrays. For example, this 5. The length is 1. The sum is 5. You can say the score of this subarray is 5, which is less than 10, right? So I think that's the complete understanding of the problem. Now, how can you solve this? See, one of the method can be that you try to find out all the subarray, which takes O of n square time complexity. What you can do, you can start with one element and try to create all the subarray which contains this element. For example, if you start with 2, then 2 is the subarray, 2, 1, 2, 1, 4, 2, 1, 4, 3, and then the complete array. This is one set of subarray which contains or which starts with 2. Then you will have to do the same process with 1. You can create this, 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 and this as a subarray, right? Now you can do this, and for each subarray you can calculate the score by taking their length and taking their sum. But this is not the optimal way, and this is not the best way to solve it. The problem category is of hard level. You need to solve it in the most optimal way possible, and we are actually going to solve it using O of n time complexity, that is in a single loop, and O of 1 space complexity without taking any extra space. How can you solve it? See, we are going to utilize an algorithm called as sliding window, right? I mentioned this in the start of this video, right? Along with this algorithm, we are going to use two-pointer technique. We are going to assign 2 pointers to the indexes of our array. The indexes of this array will be 0, 1, 2, 3, 4, right? If there are 5 elements, the indexes will start from 0 and end with 4, right? We start with 2 pointers, left and right, both will point to the same element 0. So my left is here and my right is also at the same point. At this point, my subarray is 2, right? Now to calculate the score of this subarray, what do I need? I need the sum of my subarray and the length. I can calculate the length using the 2 pointers. If my pointer left is here and my right is also here, what is the length? We know that the length is 1, but what's the formula? Okay, let me show you another example and you can actually guess the formula. If this is your left and this is your right, okay, the left is 0, right is 2. At this point of time, what is the length of your subarray? See, this is your subarray, right? 2, 1, 4. The length is 3. What can be the formula? The actual formula will be right minus left plus 1. Okay, if your left is 0, right is 0, then it will be 0 minus 0 plus 1, which is 1. That's the length. That's the length of your subarray. if this is your subarray, then it will be 2, that is the right will be 2, the left will be 0 plus 1. This will be equal to 3, right? So the length is 1, 2, 3. So every time you have a subarray using the two indexes or using the two pointers, we will know the length with these two pointers. But how can we keep track of the sum? We need the sum as well, right? What we will do is we will start with a sum of 0. We will say we have not seen any element and the sum is 0. At this point, when I see this element, what will be the sum? It will be my initial sum 0 plus 2, right? So the sum is going to be 2. And then I can just take this sum 2 and take the length using right minus left plus 1 formula and say that the score is 2 into 1, which is 2, right? And this 2 is less than 10 because the value of k is 10. So I will say this is a valid sub array which has a score of 2 that is less than k. So I am going to count this. So after processing this information, my count is going to be 1, right? I got one sub array. So once we are able to get a sub array with left here and right here as well, we are going to increase our right index or right pointer. Left will still be the same. We are going to increase the right. This is to increase the number of elements in our subarray. Now the subarray is 2, 1. Think about the basic mathematics. If you have a subarray of 2, if you increase any element which is positive, then we know that the sum multiplied by length is going to increase. It will never decrease, right? We need to find out all those subarrays which has scored less than k. We found one. So what we are doing right now is we are trying to add one more element to see if the score is still less than k or not. That is, we will keep this 2 in our subarray. We will increase the length of our subarray to see if we start with 2, add one more element to our subarray, can we have a score which is less than k or not? Okay, let us try that. This is our right index which is 1. This is our left index which is 0. The sum, the initial sum we had was 2, right? Now at this point when the left is 0, right is 1, our subarray is 2, 1. We got another element that is 1. Our initial sum was 2. So the new sum is going to be 3. And the length, I can just say right minus left, that is 1 minus 0, which is 1 plus 1. Right minus left plus 1. So 3 multiplied by 2, that's equal to 6. So the earlier score was 2, right? So let me write 2 here. So the earlier score 2 was less than k. The new score after adding one more element is still less than k. At this point of time, do you want to include this subarray in your answer? Yes, we do, right? Because this is a valid subarray which we need to count. But the real question is, how many subarrays did you got? If you will say that using this pointers, that is the left is 0, right is 1, I got one more subarray, then I would say you are wrong. And the reason is, see, we had this subarray, okay? We got 1, that's fine. But the moment I have added this element 1, I will not say I got one subarray. I will say I got right minus left plus 1 number of subarrays, that is 1 minus 0 plus 1, which is 2. I got 2 more subarrays. I will show you how we got 2 more subarrays, but let me just write it here. I got 2 more subarrays. I already had one. So at this point of time, I have a total of 3 subarrays. What are those subarrays? We know about 2 and we know about 2, 1. But there is one more subarray which is just 1. And how do we know that this is valid? That's because if 2, 1 is valid, if you remove any element out of it, that is also going to be valid. Because the score is going to decrease. It will never increase if you remove any element. So how many we need to count is the length of your subarray. So I can say using this element, I can individually form one subarray. And using this element, I can take other elements which I had previously and form subarrays. What is the formula behind it? It's just going to be the right minus left plus 1. That's the length. For example, if this is a valid subarray, let us say this is valid, okay? So your left is 1, your right is 4, right? The indexes. At this point of time, I would say 4 minus 1 plus 1. That's the formula. So I will have 4 number of subarrays. Now what is the proof behind this? See, if we do not include 5, we have already counted the subarrays using 1, 4 and 3. And once we have counted it, we try to increase the number of elements. So we said, okay, this is another subarray. Now at this point of time, I just want to know those subarrays which includes 5. So it can be 5 itself, then 5 with 3, then 5 with 4 and 3, and then 5 with 1, 4 and 3, right? So that's why I'm saying the length of your new subarray is going to be the number of subarray you need to add to your result. Alright, so the left is 0, the right is 1. We got 2 more subarrays. So once we got this as a valid subarray, we would try to increase the number of element. So this is going to be the new subarray. Left is 0, right is 2. At this point of time, you will see that the score is more than 10. Because the left is 0, right is 2. The length is going to be 2 minus 0 plus 1. That is 3. The sum, initially we had the sum as 3, right? Because we started with 0, then we added 2, then we added 1. So the sum is 3. We got another element 4. So I would say the sum is 7, right? So 7 multiplied by the length 3 is 21, which is not valid. So I would say at this point of time, if you include this, this is not valid. Starting from 2. At this point of time, I should remove some element so that I can decrease the score, right? So I would remove the leftmost element. So now the left is here, right is here, at this point of time you will see that left is 1, right is 2, the length is right minus left plus 1, which is 2. So I have a subarray of length 2. Now how can you find the sum? We already have an initial sum of 7, but this time we have removed some element. So the sum is going to be 7 minus 2, the element which we just removed. So the sum is 5. That's the sum of 1, 4, right? So the sum is 5, the length is 2, the score should be 5 multiplied by 2, that is 10, right? So at this point of time I would say this is also not valid, right? So again I will have to remove an element and not add an element to the subarray, and I am going to remove the leftmost element. So now the left is 2, right is 2, the indexes, right? And the subarray is just 4. I would say 4 is valid. That's because my initial sum is now 5. I removed an element which is 1. So 5 minus 1 is 4. The sum of my subarray is 4. The length is right minus left plus 1, which is 1. So I would say the score is 4 multiplied by 1, which is 4. So this is valid, right? Now once you get a valid element or valid subarray, you can just increase the number of elements. So 4, 3 is your new subarray. Is this valid? When you will check, this will not be valid because the sum is going to be 7 and the length is 2. So it is 14. So this is not valid. So again I am going to remove the leftmost element. So this is going to be 3. 3 will be valid. Now you will increase the subarray to 3, 5, which will not be valid. Then you will remove the element 3. Then 5 is going to be your subarray. 5 will be valid, and now you are out of your loop. So the number of subarray which you got is 2, 1, 2, 1, 4, 3 and 5, which is 6. And this is how we are going to do it. And I know that you might have a question in your mind that why should I even think about this solution? See, the thing is, if you need to deal with subarrays, then sliding window algorithm is always an option. So you can try this option and this might fit your solution, right? So that can be a thought process of solving a question which involves subarrays. Now let me jump on the code editor and show you how the Python code will look like for this particular problem. This is the complete solution of this particular problem. You initialize a variable called as result. This will hold the number of subarrays which you need to count. Then n, that is the length of your numbers or the numbers array. Then the left index, that is 0, and the total. Total will keep the track of your current subarray sum. So initially it is going to be 0. Then run a simple loop for right in range of length of nums. Okay, I can actually change it to n since we are already storing it. Now what is the new total? We are going to increase an element in our subarray, right? So that will be the nums of right. So we got a new total, right? Now start calculating the score, and the score is going to be total, that is the sum multiplied by right minus left plus 1. And in case this is more than equal to k, if it is more than equal to k, it is not valid. We should not count it. So what we are going to do is we are actually going to remove the leftmost element, and we are going to say, okay, the total is going to be total minus nums of left, and then we are going to increase the left index or the left pointer. Once we are out of the loop, we can say that, okay, we are at a point where we have got a valid subarray. And how can we calculate the number of valid subarrays? It is going to be the length of your subarray, that is result is equal to result plus right minus left plus 1. And once you come out of the loop, you can just return the value of result, and that is the complete solution for this particular problem. You can just submit the code and you will see that this is a pretty efficient solution for this particular problem. So that's it for this video, guys. If you liked the explanation of this problem and the solution as well, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.